In this lesson, we're going to be talking about the exponential function and exponential parent function and seeing how that parent function can be transformed. So let's start with, in the examples, the first exponential function is 2 to the x. So if we put out a grid of x, y's, if our x is 0, 2 to the 0 is going to be 1, because any number to the 0 power is 1. So we plug that in. So when x is 0, our y is 1. When our x is 1, our y is going to be 2. When our x is 2, our y will be 4. So that gets exponentially larger. That's going to go up like this. Let me get a more brighter color that'll pop out on this graph. This yellow should be sufficient. So we got that, and then when it's 1, 2, and then 2, 4. So it gets bigger and bigger and bigger. The next one will be 3, 9. But what about if we went to our negative x's? So if we went negative 1, 2 to the negative 1 power is going to be equivalent to 1 over 2. So that's 1/2. So here it's 1/2. And then if we had negative 2, that becomes 2 to the negative 2 is going to be 1 over 2 squared, which is 1/4. So this is going to be 1/4. So as we get more negative on our x's, our y gets smaller and smaller and smaller and smaller. It starts to approach this horizontal asymptote. It gets closer and closer to our axis. So that's our exponential function, our exponential parent function. So our first example, it wants us to simultaneously graph both y equals 3 to the x and y equals negative 3 to the x. So y equals 3 to the x, very similar to y equals 2 to the x, is just going to be it when x is 0, our y is 1. When x is 1, our y is 3. When x is 2, our y is going to be 9. So it's going to have this really steep climb, like so. And as our x's become negative, the y gets smaller. So it'll look like this. It gets closer and closer and closer to 0. That's our y equals 3 to the x. As opposed to y equals negative 3 to the x. Well, if I had negative 3, just like all of our other transformations, if you put a negative there, it's just going to flip it vertically. So if I had a number right here, remember we handle it like so. So it's not negative 3 to the x, it's 3 to the x negative version of that. That's one thing you got to be careful of, is that it's y equals, at least the order of operations, we would treat these first and then make the negative of it. So this guy is going to be, when x is 0, our y will equal negative 1, then negative 3, then negative 9. So it's the flip. Whoops, let's get rid of that. See if I can't make that look nicer. And it gets closer and closer and closer. It's just a flip of it. They want us to graph it on a graphing calculator. So if we were going to graph that on a graphing calculator, it would be done like so. You would turn on the calculator, you go to y equals. From there, you could plot out both 3 to the x as well as negative 3 to the x. You graph that out, and it should look exactly like what we did before. It's up and down. Okay, so let's do the next guy. Simultaneously graph. And really what's important about this is it reflects across the x-axis when you have a negative. But what happens if you have a 2 in front? If you're multiplying it, the stretch factor. So let's get rid of this calculator. We can keep the calculator up. So if I had here this guy, this graph, if I had, let's pick another color, y equals 3 to the x, it's going to be the same there, there, and there. We're going to, whoops, much more difficult to do this like that. It's closer and closer and closer. And y equals 2 to the 3 to the x. So I'm going to actually take this guy, copy him. We'll use him later. For now, though, what happens if I stretch this? Well, that means that all my y values will double. So if x is 0, my y will be 2. My y will be 6 here. It'll go higher. So it doubles all of these values. So it's going to look something like that. So on the quiz and the test, I want you to be able to identify that one just will be a stretch of the other, a vertical stretch. Okay. We can graph that on the calculator as well, but as long as you understand the patterns. The patterns are what are really important here. This is inside the function. Anytime I have a number inside the function, that's going to be a horizontal shift. If it was outside the function, like if we, like in example 4, that would shift it up or down. This one is going to be shifting it left to right. So let me go grab this guy that I had drawn before. Now, if I'm going to make this graph x minus, or x plus 4, 3 to the x plus 4, means that my graph will shift 4 to the left. So this guy will become here, this point will come right here, and this point will go 1, 2, 3, 4 right there. So it'll look like this. So on the quiz or test, I'm going to ask you to identify that type of graph. The next one, example 4. Let me go grab this. So for this one, we're going to shift this down 2. All of our points are going to go down 2. So I could actually just take this graph, move them. Let's change the color on that. So that's what he's going to look like. This point was shifted down 2. This point was shifted down 2. This point was shifted down 2. All of them are shifted down 2 because this minus 2 is on the outside of the function. Starting blah, blah, blah. And our final example, we're going to be going through, actually not our final example, example 5, we're going to be going through more than just one transformation. We're going to do all these transformations at the same time. So what's happening here? If I take my original parent function right here, we're going to multiply it with a stretch factor of -4. So that means it's going to flip over the x-axis. It's also going to stretch. It's going to shift over to the left 2 and down 5. So this point right here is going to shift to the left 2 and then down 5. 1, 2, 3, 4, 5. And again, he's going to open down. So this guy is also going to, so this point right here, our asymptote was at y equals 0. Our asymptote is now going to be at y equals -5. You know what? I'm going to get rid of that. Apologize. We're going to go down 1, 2, 3, 4, 5. So our new asymptote is going to be here. And if I was to plug in this being 0, if x is 0, this becomes 0 plus 2, which is 2. 3 squared is 9. 9 times -4 is -36. Minus 5 is going to be -41. So when x is 0, we got this. This guy is way down here. It's not going to be realistic for us to graph it. What I need you to understand is that it's going to flip over the axis. It's going to go down 5. It's going to go left 2 because it's the opposite when it's on the inside of the function, and it's going to have a stretch of 4. So it's going to look like 1, 2, 3, well, way down there, because when this is -2, this guy would be -9. So that would be that point. And you would see something like this. And it's really going to stretch down. Blah, 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 if they're all greater than 1. Now, if we were dealing with bases that are less than 1, like 1/3, if we were to plot that out, let's plot out our x and y values here. So if our x is 0, again, our y is still 1, because anything to the 0 power is 1. If x is 1, we've got 1/3. If x is 2, we've got 1/9. If x was -1, that would be 1/3 to the -1, which is just 3. When x is -2, this would be 9. So it's very similar to our graph right here, what we had before, except it's going to be flipped. So, you know what, let's get rid of this. Let's just draw it fresh. So when this is that, this would get smaller and smaller and smaller, and this guy would get bigger and bigger. So when we have a base that's less than 1, it more or less does a horizontal flip across this y-axis. And that's the beginning of the unit. And we're going to continue on with these exponential parent graphs in the next one.